Solving graph linear inequalities. So first you need to be able to read the inequality. So on the left is the less than sign, which looks like an L. On the right is the greater than sign, which does not look like an L. So that's the way that I explain it. I know you can look online and there's some alligator examples of eating the bigger number, things like that. So we're going to solve this inequality and then graph it. Negative 6 plus x is greater than or equal to 0. So we solve inequalities the same way we solve equations. So if you imagine that inequality as an equal sign, we're doing the same process. So that negative 6 plus x, if I wanted to rewrite it, that would be positive x minus 6. So we're going to be adding 6 to both sides of the inequality, since those are equal. X is greater than or equal to 6. So this is our solution. So when we graph the solution set on a number line, you have to have the number 6 somewhere on that number line. I always like to plot 0 because comparing 6 and 0 is going to be easy. 1, 2, 3, 4, 5. You don't have to put all these numbers for me, but follow your teacher's directions. If the inequality is greater than and your variable is on the left side, that inequality is telling you which direction you're going to graph. So from 6, we are going to graph to the right, and all of our solutions are going to be in this direction. So those numbers are going to be 7, 8, 9. All of these numbers are greater than 6. We also want it to be equal to 6. So we're going to plot a point at 6. We're going to circle that point in. That's going to be our graph. So if we look at another example, solve the inequality, graph it. This is 3 times x is less than negative 18. The opposite of multiplying by 3 is dividing by 3. So that's what we're going to do. X is less than negative 6. So again, in graphing an inequality, for me, I want to make sure that I have negative 6. I'm going to have an open circle at negative 6 because there is no equal sign. So it's not an equal to. And my variable's on the left. So if x is on the left, that inequality is telling me which way to graph. So I'm going to graph it to the right. So numbers that are less than negative 6 include negative 7, negative 8, negative 9, and so on. 0 is going to come all the way over here. So the further you get from 0, the larger the numerical values become, like 6, 7, 8, 9. So this other equation is very similar, but very different. So the difference here is I just took the negative off the 18 and put it on the 3. So we have negative 3 times x is less than 18. So now we're going to divide by negative 3 on both sides. So there's a fancy rule. If you divide by a negative number, the inequality must flip. So what I like to do is circle this inequality so that I know it's going to happen and change it now before I do any other work. So negative 3's are going to divide and give me 1. And now x is greater than negative 6. That is my solution. So when I graph it, that's what I'm going to get. For understanding purposes, let's say this is option A, right? Option B. If I were to take this equation and I were to move things around, if I added the 3x to the right side and I moved it over here, and I subtracted the 18 to both sides, and I moved it to the left, I can rearrange this equation, and I would get negative 18 is less than 3x. So if negative 18 is less than 3x, I can rewrite this as 3x being greater than negative 18. So now if I divide by 3, I get x is greater than negative 6. So the answer is the same. The reason I'm showing you this part, B, is because this is the y. This is why we switch the inequality when you divide by a negative. Now in terms of graphing, we have a number line, negative 6, and since x is on the left side of that inequality, we're moving to the right. So open circle, and we're going to go to the right, towards 0. Going towards 0, our numbers are going to get smaller. And that's how you solve and graph linear inequalities.